Hello, I am Ahmad, and in this video, I'm going to talk about environmental class, a structural class, and also the calculation of nominal cover for the concrete structures according to Eurocode 2. Let's start. So what nominal cover means, if we have a concrete element, it can be a beam, it can be a column, it can be a slab. So let's start with a concrete beam. The longitudinal reinforcement usually takes the bending moment, and they are designed for tension. We have reinforcement in compression as well, but mainly for tension. And also we have the shear reinforcement, which is called stirrups. They are designed for the shear force of the element against the tension in other planes. Now, if we look at the cross section of the element, these are the longitudinal reinforcement and these are stirrups. Now, if we have a close look to the corner of this beam or element, it's the ribs around the reinforcement. And this is the stirrup. With the ribs. So the nominal cover that we need to provide is the distance between the concrete surface to the edge of the ribs of the stirrup, if we have a stirrup. For example, for the slabs, there might not be any stirrup, so we can extend it up to the first touching the rib of the longitudinal reinforcement. So in the other direction also. And according to Eurocode, we need to, or any other codes, we need to provide sufficient distance for this cover to ensure that the reinforcement is not harmed by any other issues like environmental action It can be in a very aggressive condition, or it can be in a very safe, like inside a house, and it could be dry. For any class of the use of the structure, we have the minimum needed or required nominal cover. How to calculate it? We need to have a look on Eurocode. According to section 4 of Eurocode 2, durability and cover to reinforcement, in clause 4.1, general number 1, its principle, a durable structure shall meet the requirements of serviceability, strength, and stability throughout its working life, without significant loss of utility or excessive unforeseen maintenance. And also number 2, the required protection of the structure shall be established by considering its intended use, design, working life, based on Eurocode 1990, maintenance program, and actions. So for this reason, we need to calculate the minimum cover. There is also another point that we need to consider nominal cover to fulfill the criteria, which is for the fire safety. Usually for ordinary structures under a very standard fire protection, this nominal cover would be sufficient. But in exceptional demanding projects, perhaps we need to consider also Eurocode 1992-1.2. This is for Eurocode 1992-1.1, general rules for concrete structures. So again, according to Eurocode 1992-1.1, clause 4.2, environmental condition, exposure conditions are chemical and physical conditions to which the structure is exposed in addition to the mechanical action. Environmental conditions are classified according to table 4.1 based on EN 206-1. So as a result, for considering our calculation of the minimum nominal cover, we need to check what kind of a structure we are designing. So in table 4.1, we can see different exposure class for our condition. No risk of corrosion or attack, X0, which is for concrete without any embedded metal or reinforcement. Number 2, corrosion induced by carbonation, and number 3, corrosion induced by colorides. So we can select, and so also there are many more options for other exposure class that you can check the Eurocode for finding the suitable structural exposure class of the project. XC1 and XC2 are the more dominant exposure classes that are used. The first one, XC1, is dry or permanently wet, which there is also informative examples where exposure classes may occur. For example, here, concrete inside buildings with low air humidity. And also concrete permanently submerged in water. The reason that these two are in the same class is that if the concrete is inside the building, it is not in contact with humidity that much. As a result, it is not susceptible to be corroded by the oxidation of the reinforcement. And also, if the element is permanently submerged, then it's also similar to being completely dry. So it means that the part or the element which is submerged is not in a position to have interaction with air. As a result, there would not be any oxidation, and we can assume that these two are in the same category. So that category is called XC1, and we need to find this exposure class in the drawing, or if you are designing, you need to write down XC1 if it is relevant. The next one is XC2, wet or rarely dry concrete surfaces subject to long-term water contact. For example, many foundations. Even in the summer, we might have some humidity inside the soil. As a result, these type of structures, linear foundations, pile caps, these type of structures are wet, rarely dry. As a result, they are categorized in XC2. XC3, moderate humidity, concrete inside buildings with moderate or high air humidity, external concrete sheltered from rain. And XC4, cyclic wet and dry, concrete surfaces subject to water contact, but not in the exposure class XC2. Usually the exposure class needs to be agreed by the customer or the client for the project. And number 3, corrosion induced by colorides, XD1, XD2, and XD3. This is different from the first one. The first one is carbonation, the other one is for contact with colorides. The same concept, moderate humidity, wet, rarely dry, cyclic wet, and dry. But the examples are a little bit different. For example, concrete surfaces exposed to airborne colorides, XD1. Swimming pools, concrete components exposed to industrial waters containing colorides, that's also in this category. And parts of bridges exposed to a spray containing colorides, pavements, car park slabs, these are usually under the attack of coloride. As a result, the corrosion would be because of colorides. As a result, they are not XC, they are XD. And so on. You can check the other relevant exposure class in Eurocode for more detail. So first of all, we need to understand what kind of exposure class we are dealing with. After finding out what kind of exposure class is our project, we need to verify the concrete cover. Methods of verification is given in the Eurocode 1992-11 clause 4.4, and the first one is concrete cover. The concrete cover is the distance between the surface of the reinforcements closest to the nearest concrete surface, including links and stirrups and surface reinforcement where relevant. And the nearest concrete surface. So this is the explanation I explained earlier in the beginning. And in number 2, the nominal cover shall be specified on the drawings. I mentioned this as well. It is defined as a minimum cover C minimum plus an allowance in design for deviation, delta C deviation. So the C minimum is given in clause 4412 and delta C deviation is given in clause 4413. And the equation for calculating this C nominal is given in equation 41, C minimum plus delta C deviation. Minimum cover C minimum is given in clause 4412 of Eurocode 2. Minimum cover concrete shall be provided in order to ensure the safe transmission of bond forces. So we know that we want to explain this a little bit, how it works. When we want to calculate what is the anchorage length of a reinforcement, if this is the concrete, and assume that your longitudinal reinforcement is somewhere here, for example. And assume that this rebar is designed for tension. So if we apply the tension, and if it is very close to the surface, then the bond assumption, we assume that the concrete is bonded with the concrete together. But if it is very close, then this assumption might not be valid. As a result, we need to ensure that C minimum, because of bond, is provided. The protection of the steel against corrosion. So the other case is for the durability. So two options or two conditions. for bond and also for durability. And the third one, which is related to fire safety. So if it's very ordinary structure, perhaps it is fulfilled. But if it is designed for a very long time of fire, then we need to increase the C, which is not fit in this video. So now we are going to calculate C minimum. The greater value for C minimum satisfying the requirements for both bond and environmental conditions shall be used. So C minimum is given as equation 4.2 maximum of 3 values: C minimum B, which is related to bond, C minimum durability, and 10 millimeter as a constant number. So C minimum durability can be found in clause 44123. C minimum durability can be found in 44125, and the additive safety element reduction of minimum cover for use of stainless steel, reduction of minimum cover for use of additional protection, these can be found in the relevant clauses as written in the Eurocode. The recommended value in the code is 0, but if you are in a country that the national annex suggests a certain amount, you can use them. For simplicity, in this video, we use delta C durability, gamma, stainless steel, and additional protection are considered to be 0. So if we simplify this according to the recommended value in Eurocode, C minimum will be maximum of C minimum bond, C minimum durability, and 10 millimeter. So now we need to calculate C minimum bond, which is given in the relevant clause, the same code. In order to transmit bond forces safety and to ensure adequate compaction of the concrete, the minimum cover should not be less than C minimum B, given in table 4.2. Bond requirement, arrangement of bars, and also minimum cover C minimum B. And the star represents a note, footnote in the table, as we can see. If we have separated reinforcement, like this type of ordinary reinforcement, then C minimum bond will be the diameter of the bar. Very simple, very straightforward. But if we have bundled, if you have, for example, a very big element, enormous element, then you might need to use, for example, 2 reinforcement together and bundle them together. In that case, then you need to calculate the C minimum bond according to bundled equivalent diameter. You can find how to calculate phi n from the clause 891, and then that will be C minimum B. Then we need to calculate the durability cover, which is given in the other clause. After calculation of minimum bond cover, we need to calculate the minimum or the required C or cover for the durability. According to the same clause, but number 5, the minimum cover values for reinforcement and pre-stressing tendons, nominal weight, concrete taking account of the exposure classes and the structural classes is given by C minimum durability. So here This is the item, and here is where we can find C minimum durability. There is an important note: a structural classification and values of C minimum durability for use in a country may be found in its national annex. The recommended structural class design working life of 50 years is S4. For the indicative concrete strengths given in Annex E, and the recommended modification to the structural class is given in Table 4.3. The recommended minimum structural class is S1. So, for calculation of C minimum durability, we need to know what kind of a structural class we have. And after finding the structural class, we need to modify it by the given information in Table 4.3. We will go through that. And then we need to find out the recommended values of C minimum durability in Table 4.4n for reinforcing steel and for 4.5n in pre-stressing steel. This is not related to pre-stressing. As a result, I will just go through Table 4.4n. So first, we need to check Table 4.3n and then Table 4.4n. And according to the recommended note here, we start always with structural class S4. We go with S4 and then we modify it. Let's check how to do it. Table 4.3n, recommended structural classification criterion, exposure class according to Table 4.1. So first, we need to find out what kind of exposure class we have according to Table 4.1. We went through that. X0, XC1, 2, 3, 4, XD1, 2, 3, or others. And then we need to check the other criterion here. Design working life of 100 years. Strength class. Member with a slab geometry. Position of reinforcement not affected by construction process. A special quality control of the concrete production ensured. For example, for the latest criteria, we can say that if we are concreting in the factory and it's not in the site, then we can have a very high quality or a special quality control for the manufacturing of the element. In that case, we can say that we have a high quality or a special quality control, and then we might be able to reduce the class. And sometimes we are dealing with a structure which is with a longer working life for 100 years, then S4 is always for working life of 50. So let's have a very simple example and then find out how it would be our case. Example, foundation for a structure with 100 years working life, and it is with C3545 concrete, and it's a beam, and also no special quality control. So first we need to find out what kind of exposure class do we have. If you remember, for the foundations, it is XC2. And then we need to find out what kind of a structural class do we have. We start always with S4, and then we come to the table 4.3. XC2, we are here. And design working life is 100 years. So then we need to increase the structural class with 2. So it will be S6. Then a strength class of the concrete. We are using C3545. It's equal or greater than that. So we can reduce it by 1, so it will be S5. Then it's not a slab geometry, it's a beam, so this is not applied, and also there is no special quality control. As a result, our structural class for this case will be S5. That's simple. After that, we can find out what is the durability cover according to table 44N. We will go through the same example. So here in table 4N, according to a structural class that we have, and also exposure class of the structure, we can find out the minimum durability cover. For example, for our example, it was S5 and XC2. So S5 and XC2. Then C minimum durability will be 30 millimeter. So one note in this clause that is important to be considered is number 11. If you have a roughened surface, for example, it's a pavement, you want to have a slope, it's a balcony, and you want to have a reasonable slope, then for uneven surface, e.g. exposed aggregate, the minimum cover should be increased by at least 5 millimeter. We need to increase this by 5 millimeter. You calculate according to the minimum cover, and then we can add 5 millimeter to that. So again, coming back to our first equation, so C minimum is always the maximum value of C minimum bond, C minimum durability, and 10 millimeter. And then C nominal is always C minimum plus delta C deviation. For this deviation, we have another clause in Eurocode 4413. To calculate the nominal cover, C nominal and addition to the minimum cover shall be made in design to allow for the deviation, delta C deviation. The required minimum cover shall be increased by the absolute value of the accepted negative deviation. The value of delta C deviation for use in a country may be found in its national annex. The recommended value is 10 millimeter. We use 10 millimeter here, but notice that always check the national annex if there is any statement about this, any notes that are referring to national annex of a country. So 10 millimeter. And also we have another important clause in this case. For concrete cast against uneven surface, for example on the ground, the minimum cover should generally be increased by allowing larger deviations in design. The increase should comply with the difference caused by the unevenness, but the minimum cover should be at least K1 millimeter for concrete cast against prepared ground. If you have a prepared ground, then K1, which is recommended to be 40 millimeter, is the minimum, including blending. And K2 millimeter for concrete cast directly against the soil. If you do not have a prepared ground, then it is perhaps against the soil. Then you need to have the minimum K2 millimeter, which is 75 millimeter. So that's something we need to consider. The cover to the reinforcement for any surface feature such as ribbed finishes or exposed aggregate should also be increased to take account of the uneven surface. D441211 that we already went through that. It was here. So exposed aggregate, then 5 millimeter should be added. This is the minimum. So now we can have a simple example to find out what is the minimum or nominal cover of the concrete for one beam, for example. Suppose a concrete beam is designed for a swimming pool. With working life of 100 years. The concrete class is going to be C4050 and a special quality control is ensured. The available reinforcement is T25. So it means that we are going to use T25. What is the required nominal power? So let's write the summary of the example. It's a beam in swimming pool, and for 100 years, working life C4050, a special quality control, and T25. So first of all, we need to know what kind of exposure class is our structure. Coming back to table 4.1, swimming pool XD2. And then we need to find out what is the minimum bond cover. Minimum bond cover, there is not any mention about if the reinforcement is bundled. As a result, we assume that they are separated. So C minimum B is the diameter of the bar. Which is 25 millimeter. Then we need to determine what is the structural class. So XD1 design working life is 100, so it is increased by 2. S4 plus 2 S6. We are using C4050, we can reduce by 1, so it is S5. So position of reinforcement would be affected by construction process, for example, so we can ignore this part, and a special quality control we can reduce by 1. So then it is increased by 2, then it is reduced by 1 and 1, so it will be S4. S4 plus 2 minus 1 minus 1 S4. And then from the table 4.4n, so S4 and XD1, so it is 35 millimeter. Then we can calculate C minimum, which is the maximum value of C minimum bond, C minimum durability, and 10 millimeter. So it will be maximum of 25 millimeter and 35 millimeter and 10 millimeter. So which is 35 millimeter. Now C nominal is C minimum plus delta C deviation, which is 10 millimeter. So 35 millimeter plus 10 millimeter will be 45. If the value of this, especially if you have bundled, then perhaps this equivalent diameter will be something like let's say 40.2, 28 point something, 30. So it is not a value by the interval of 5 millimeter. As a result, C nominal will not be a good number for the construction. Let's say if it is 42.3 millimeter, it is advised to round it to the next 5 millimeter or even the next 10 millimeter. If you calculate this C nominal to be 45 millimeter and you have enough space, then 50 millimeter would be quite fine. Or you can write down that the C nominal in this project for these elements should be taken as 45 millimeter. So let's recap and write down from where we take these values. For swimming pool, we go to table 4.1 and determine what is the exposure class. Then from table 4.2, we calculate C minimum B. From table 4.3n, we determine the structural class. And from table 4.4n, we determine C minimum durability. And then from the equations given in Eurocode, we can calculate C minimum and C nominal. In the main drawing, it should be written clearly that this is the nominal cover that we need. That's what should be done. Yes, in this video, we went through the calculation of nominal cover of concrete structures, and we covered the exposure class and also a structural class according to chapter 4.4 of Eurocode 1992-11. And also we calculated the required nominal cover for one example, and I hope you use it for your project. Thank you for watching. See you. Bye.